There is a moment, if you stand at the right angle on Fifth Avenue and tilt your head all the way back, when the Empire State Building stops looking like a building. It becomes something else, a silver needle threading the sky, a monolith so perfectly proportioned, so quietly dominant over everything around it, that your brain silently refuses to process what it's actually looking at. It refuses to accept that human hands assembled this, piece by piece, bolt by bolt, beam by beam, in the middle of one of the noisiest, most chaotic cities on Earth. 410 days. That is how long it took to build. Not years, not decades. 410 days. In today's world, that timeline would be considered extraordinary for a mid-size office building. But the Empire State Building is 102 stories tall. It weighs roughly 365,000 tons. It was built in 1930, when there were no computers, no digital blueprints, no laser-guided cranes operated from climate-controlled booths. Workers moved structural steel with their hands. Rivets were heated over open fires and tossed through the air to catchers waiting dozens of floors above the street. And here is the part that most people never think about. The men who built this thing, the ones who funded it, who drew the plans, who made the decision to go, they started construction after the worst financial collapse in American history. They broke ground on the Empire State Building while people across the country were losing everything they had. They built the world's tallest skyscraper during the Great Depression. Why? Who pushed for this? Who stood to gain? And how on earth did they actually pull it off? That's what we're going to find out. If you enjoy learning how the world's most incredible engineering projects actually work, the real planning, the real problems, the moments that almost destroyed everything, consider subscribing. On this channel, we break down the science and the stories behind the structures that define our world. Now let's go back to 1929. To understand why the Empire State Building exists, you have to understand the specific brand of ego that ran New York City in the 1920s. The city was obsessed with height, not just as a symbol of progress, as a competition, a live, public, almost sporting event. Newspapers tracked which skyscraper was going up fastest. Business executives measured their status by the number of floors their company could claim. And in the late 1920s, that competition had reached its most extreme form yet, because 3 different buildings were racing to become the tallest structure in the world at exactly the same time. There was 40 Wall Street, the Chrysler Building, and the project that would become the Empire State Building. The Chrysler Building's story is worth stopping on for a moment because it changes everything that comes after. Walter Chrysler, the automobile magnate, was building his tower on Lexington Avenue. His architect, William Van Allen, had originally designed it to reach about 925 feet. But then the developers of 40 Wall Street revised their own plans upward to beat Chrysler's height. So Van Allen quietly redesigned the top of the Chrysler Building and said nothing publicly about it. What happened next is one of the great moments of architectural theater in history. After 40 Wall Street topped out, convinced they had won the race, the Chrysler Building's crew hoisted a 125-foot spire, secretly assembled inside the building's dome, through the roof in just 90 minutes. The Chrysler Building instantly became the tallest structure on Earth at 1,046 feet. The whole city was stunned, but not for long, because John Jakob Raskob had already been thinking much, much bigger. Raskob is not a name most people recognize today, but in the 1920s he was one of the most powerful financiers in America. He had served as vice president of finance at both DuPont and General Motors. He understood capital at a scale that most people couldn't imagine. And he had a quality that both drove his success and nearly destroyed him. He was constitutionally incapable of doing anything at a moderate scale. In the summer of 1929, just 2 months before the stock market crash, Raskob had published a famous magazine article urging ordinary Americans to invest in the market. The title was "Everybody Ought to Be Rich." It aged poorly. But before that crash, Raskob had assembled a group of wealthy investors, including Pierre DuPont and several banking institutions, and purchased a prime plot of land at the corner of 5th Avenue and 34th Street in Manhattan. The site housed the original Waldorf Astoria Hotel, one of the grandest hotels in the world. The plan at first was relatively sensible. A 50-story office building, respectable, practical, the kind of building that makes money. Then Walter Chrysler pulled his stunt with the spire. And Raskob, furious and humiliated, called his architects back and told them to redesign. Make it taller, much taller. He famously held up a pencil in a meeting and said, "Build it to look like this. Tall, elegant, perfectly tapered." The architects, the firm of Shreve, Lamb and Harmon, reportedly produced the initial design in just 2 weeks. The building went through 15 revisions before a final version was locked in. Each time the Chrysler Building added height, the Empire State Project added more. When the Chrysler Building settled at just over 1,050 feet, Raskob pushed his building to 1,050 feet as well, and then decided that wasn't enough of a margin. So he added a mooring mast for airships, a 16-story, 200-foot tower at the top, supposedly designed to allow transatlantic zeppelins to dock directly above Midtown Manhattan and let passengers disembark onto the 102nd floor. It was partly a genuine idea, partly a stunt to add height, but it pushed the total to 1,250 feet and ended the skyscraper race, not just for that year, but for the next 41 years. Now Raskob had his numbers, he had his architect, he had his vision. What he needed was a construction team willing to do something that had never been done before, and that is where the real engineering story begins. Here is the core problem that made this project almost impossible. It wasn't just the height. Tall buildings had been built before. The challenge was the combination: extreme height, extreme scale, and an absolutely non-negotiable deadline. The building had to be ready for occupancy by May 1st, 1931, just 18 months after construction began. That was not a preference. That was a hard deadline written into the financial agreements. The architects faced a fundamental conflict from day one. Normally, a building of this complexity would be designed in full before a single shovel broke ground. You finish the drawings, you verify the structural engineering, you approve every system, then you build. That's how it works. The Empire State Building did not work that way, because the deadline left no time for that sequence. So they did something that still feels radical. Design and construction happened simultaneously. The structural steel drawings were finalized in mid-January 1930, when excavation of the foundation was already underway. Upper floor designs were being finalized, while the lower floors were already rising. Some floor specifications were being approved with less than an hour before the materials for that floor had to be ordered. Think about what that means. The builders were constructing a 102-story skyscraper, the largest building project in history at that point, without knowing exactly what several of the upper floors would look like. They were building blind, trusting that the engineers would keep pace with the steel. It should not have worked. And yet. The demolition of the old Waldorf Astoria Hotel began on October 1st, 1929, the same month the stock market crashed. Within weeks, America was in free fall. Banks were failing, businesses were closing, millions of people were losing their jobs and their savings. And on the corner of 34th and 5th, workers were breaking up the floors of one of the most glamorous hotels in the world, brick by brick. The decision to continue was not sentiment. It was math. Raskob and his investors had already committed enough capital that cancelling the project would cost more than finishing it. A $27.5 million loan from the Metropolitan Life Insurance Company was secured in December 1929 to keep things moving. They were past the point of retreat. By January 22, 1930, excavation of the site began in earnest. 2 12-hour shifts, each consisting of 300 workers, dug continuously day and night. They needed to go 55 feet down into Manhattan bedrock, deep enough to anchor the foundations of a building that would eventually weigh close to 365,000 tons. Small pier holes were drilled into the rock to house concrete footings, each one designed to hold an enormous column load. 4 of the central columns positioned in the core of the building would eventually support a combined load of 10 million pounds. The foundation was complete by March, and on March 17, 1930, St. Patrick's Day, the first steel column was set. What happened next was not just construction, it was something closer to a military operation. The structural steel, all 57,000 tons of it, was fabricated off-site by 2 Pennsylvania companies, American Bridge Co. and McClintic Marshall. To put that in context, the Chrysler Building used 21,000 tons of steel. The Empire State Building used nearly 3 times that amount. The steel for the Empire State was so massive that when it was compared to Chicago's Merchandise Mart, then the world's largest building by floor area, it exceeded even that. Every single piece of steel was pre-cut, pre-drilled, and coated with a marking that told workers exactly where in the building it belonged and which derrick would lift it. The steel traveled from Pennsylvania by rail to a supply yard in New Jersey, then by barge across to an East River pier, then by truck to the site. There was no storage space on the building site itself. The lot was too small, so the steel was ordered and delivered in a sequence called just-in-time delivery, 2 floors at a time, coordinated so that each batch arrived exactly when the workers were ready for it. If a delivery was late, the entire schedule collapsed. The derrick system used to raise the steel was itself a feat of engineering. Because of the building's stepped setbacks, the way it narrows as it rises, following New York City's 1916 zoning laws, standard cranes couldn't reach over the recessed upper floors, so the engineers designed relay derricks with 75-foot booms and 82-foot masts, mounted on platforms cantilevered out from the building's face. The erecting derricks climbed with the building, rising floor by floor as the steel grew. By June 20, 1930, just 3 months after the first column was placed, the steel had reached the 26th floor. By September 19th, it had topped out at 1,048 feet, 23 weeks from the first piece of steel to the full structural height of the building. During July of 1930 alone, 22 stories of steel were placed in 22 working days. At the absolute peak, the crew was completing 4.5 stories per week. The previous world record for a building of comparable height had been 3.5 stories per week. Now here's something that most documentaries skip over. And it matters, because it gives you the most visceral sense of what this construction actually looked like. There was no welding, not a single weld in the entire steel structure. Every joint, every connection, every beam secured to every column, all of it was done with rivets. And the way rivets were installed in 1930 was almost primitive by modern standards, except it was performed at extraordinary speed by teams who were extraordinarily skilled. Each rivet gang had 4 members: a heater, a catcher, a bucker-up, and a gunman. The heater would take a raw rivet in a short pin of steel and heat it in a portable furnace until it glowed orange-red. Then, using tongs, the heater would throw it into the air. The catcher, working anywhere from 1 to several floors below or above, would catch the glowing rivet in an old paint bucket. The catcher would transfer it to the hole with tongs, the bucker-up would hold it from the backside, and the gunman would hammer it flat with a pneumatic riveting gun until it cooled and locked itself permanently into the steel. This was done hundreds of thousands of times, across every floor, at every height, in all weather conditions. Workers were riveting steel on open beams 80 stories above street level, with no safety harnesses, no nets, and no fall protection of any kind that would be recognizable today. The photographs taken by Lewis Hine during this period, showing workers perched on girders with the Manhattan skyline behind them and nothing below, have become among the most iconic labor images in American history. The workforce at its peak reached 3,139 workers in a single day, August 14, 1930. Many were Irish and Italian immigrants. A significant number were Mohawk ironworkers from the Kanawake First Nations Reserve near Montreal, who had developed a reputation as some of the best high steel workers in the world. They worked on projects like this because they were willing to, and because they were extraordinarily good at it. 5 workers officially died during construction. Some historians believe the actual number was higher, though the official records are what they are. The project was considered remarkably safe for its era, given the scale and the conditions, but the steel was only one piece of the puzzle. While the frame was rising, tens of millions of pounds of other materials had to get to the right floor at the right time. Stone, brick, concrete, marble, glass, copper, aluminum, all of it moving constantly through a building that was simultaneously under construction and serving as its own supply chain. The solution was a miniature railway system inside the building itself. Narrow-gauge tracks were installed on each floor as it was completed. Small carts, capable of carrying several times more material than a standard wheelbarrow, were loaded at a central receiving area and pushed along the tracks to wherever they were needed. At the building's peak, workers installed approximately 300 to 400 bricks per day. The 6,500 windows were prefabricated off-site, designed to be part of the wall rather than set into traditional stone openings, a curtain wall approach that reduced the stone needed by 75% compared to earlier skyscrapers. The efficiency was deliberate and obsessive. To keep workers from losing time traveling to the ground level for meals, the project managers installed cafes and concession stands on 5 of the unfinished floors. Water taps were set up on multiple levels. Every minute a worker spent walking to and from the ground was a minute not spent building. The whole operation was engineered like a factory. The building was both the product and the production line. And while all of this was happening above ground, the architects were still finalizing the upper floors below ground, or rather in their offices. When a supplier couldn't deliver Black Hauteville marble in time for an interior section, the team sourced Rose Formosa marble from a German quarry, bought the quarry outright for the project, and had the material shipped and installed on schedule. Nothing stopped, nothing waited. But here is the part where the story gets more interesting. Because not everything went smoothly. The steel had been pre-ordered based on an anticipated change to New York City's building codes, a change that would have allowed structural steel to carry 18,000 pounds per square inch of load, up from 16,000. That difference sounds small. It isn't. It affects how much steel you need to build a structure of a given height, which affects cost and weight and schedule. The code change had been safely implemented in other American cities, but in New York, it required the mayor's signature, and Mayor Jimmy Walker had not yet signed it when the steel was already on order, and the foundation was already being dug. If Walker didn't sign in time, the entire structural calculation for the building would need to be revised. The steel that had already been ordered and fabricated might not meet the old code's requirements. The construction schedule would collapse. Walker signed the new code on March 26, 1930, just days before the first steel was to be set. The margin was that thin. And there was a second problem hiding inside the building's steel that most people have never heard about. The original design called for the structure to resist wind loads through the frame itself, a fully riveted steel skeleton stiff enough to handle lateral forces from the wind at any height. The structural engineer, Homer Gage Balcom, was one of the first engineers in America to systematically design skyscrapers around wind as a primary force. His calculations showed that the Empire State Building's frame would be significantly stiffer than comparable structures, a structural stiffness of 42 pounds per square foot, compared to buildings that came decades later that achieved only 26 or 33. But achieving that stiffness required the extraordinary amount of steel that made this project unlike anything before it. Every number mattered. Every calculation had to be right. On November 21, 1930, the mooring mast was hoisted into place. It was, on one level, the most audacious part of the whole project, and on another level, one of the least practical ideas ever seriously pursued by a major construction project. The concept was this: transatlantic Zeppelin airships, which in the late 1920s were considered a serious future mode of travel, would cross the ocean and dock at the top of the Empire State Building. Passengers would disembark onto the 102nd floor. The lines holding the airship would be secured to the mast. A few test attempts were actually made. They failed, as anyone who has thought about it for more than 30 seconds might have predicted. A 776-foot-long airship trying to hover over Midtown Manhattan, with all the turbulence, thermal activity, and wind variation that a dense urban skyline creates, is not something that can be easily controlled. The whole idea was quickly abandoned. But the mast stayed, and it served a different purpose entirely. In 1952, a 222-foot television and radio antenna was installed atop the mast, turning the building into the dominant broadcast point for New York City and generating significant additional revenue for the owners. What began as a publicity stunt became one of the most practically useful features of the structure. The spire also did something that no one explicitly planned for. It made the building iconic. A building that tapered cleanly and then simply ended would have been impressive. A building that tapered, narrowed to a platform, and then launched a 200-foot needle skyward, became unforgettable. The silhouette of the Empire State Building is one of the most recognizable images in the history of architecture, and that silhouette is defined almost entirely by the mast. On May 1, 1931, President Herbert Hoover pressed a button in Washington, D.C., and the lights of the Empire State Building came on for the first time. The building had been completed in 410 days. It was finished a full month ahead of schedule. The final cost was approximately $40.9 million, nearly $20 million, under the original budget of $60 million. The Great Depression had done something that the owners had not expected. It had driven down the cost of labor and materials to such a degree that one of the most ambitious construction projects in American history came in under budget. The opening ceremony was attended by dignitaries, by press, by thousands of New Yorkers who stood in the streets of Midtown and stared upward. The 86th floor observation deck attracted 17,000 visitors in its first 4 days. People paid $1 for admission, roughly $20 in today's money, and they came in enormous numbers. The city was suffering desperately and visibly, but people still found a way to pay $1 to stand at the top of the world's tallest building and look out at everything below them. It was, whatever else it was, an extraordinary thing to see. But behind the ceremony and the spotlight, a more uncomfortable reality was already becoming clear. This is the part of the Empire State Building story that the tourist brochures leave out. The offices were empty. When the building opened, demand for new commercial office space in New York had essentially collapsed. The Great Depression had gutted businesses across every industry. Companies weren't expanding. They were contracting. They weren't looking for new floors in a brand new skyscraper on Fifth Avenue. They were trying not to go under. In the early years, express elevator service ran from the ground floor only to the 25th floor because there were no tenants above that. The floors between the 26th and 80th were dark, unfurnished and unrented. The only reason to run the elevators past the 25th floor was to get visitors to the observation deck on the 86th. New Yorkers, with their particular gift for cruel accuracy, started calling it the Empty State Building. The observation deck saved them. By 1938, it was generating $1 million in annual revenue, which was, at that point, roughly equal to the rent income from whatever office tenants they did have. Raskob, who had publicly urged the entire country to invest in the stock market just before the crash, now found himself doing something he apparently despised, putting his own personal money into the building to keep it financially alive. The Metropolitan Life Insurance Company, one of the original lenders, eventually moved employees into the building simply to help stabilize its occupancy numbers. The building did not turn a profit until the early 1950s. By then, the post-war economic boom had transformed demand for office space. The building filled up. By 1961, when a real estate syndicate purchased it for $65 million, then the highest price ever paid for a single building, the New York Times described it as one of the most profitable commercial properties in the world. The same building that a generation earlier had been a monument to ego and miscalculation had become, through time and patience and a changing economy, enormously valuable. Raskob never saw that vindication. He died in 1950, just as the building was beginning to turn the corner. The Empire State Building was not just a tall building, it was a proof of concept for an entirely new way of thinking about construction. The just-in-time steel delivery system, ordering and receiving materials 2 floors at a time with no on-site storage, was a direct application of industrial manufacturing principles to large-scale construction. The internal railway system on each floor, the prefabricated curtain wall panels, the concurrent design and build process, the organized division of labor among more than 60 subcontractors working simultaneously. These were not standard practices in 1930. They became standard practices because the Empire State Building demonstrated that they worked. The American Society of Civil Engineers recognized this in 1955, naming the building one of America's 7 modern civil engineering wonders, alongside the Hoover Dam, the Panama Canal, and the Golden Gate Bridge. In 1996, ASC named it one of the 7 wonders of the modern world. The structural stiffness of the building, that 42 pounds per square foot figure, remained genuinely impressive compared to skyscrapers built decades later with far more sophisticated engineering tools. The building held the record as the world's tallest structure until 1967 as a freestanding structure, and as the world's tallest office building until 1972, when the North Tower of the World Trade Center surpassed it. It was the tallest building in New York City again after September 11, 2001, a title it held until One World Trade Center was completed in 2014. Here's what people don't think about when they look at the Empire State Building. The building is not static. It never has been. On a moderately windy day, the top of the building can move laterally by about 1 inch. In extreme wind conditions, structural engineers have measured sway of up to several inches. The riveted steel frame, designed specifically to handle lateral wind loads, flexes rather than resists. Like a tree in a storm, it moves with the force rather than fighting it. That movement is imperceptible to people inside, but it's measurable. The building has 73 elevators. When it opened, the Otis-supplied cars could travel 200 feet per minute, fast enough to take a passenger from the ground floor to the 80th floor in under 60 seconds. That elevator speed, like the steel load allowance, required a special negotiation. The building's owner, Al Smith, personally convinced the relevant authorities to approve the increased speed in time for construction. Without it, the building's operational efficiency would have been significantly compromised. The building also has 6,500 windows, 1,860 steps from ground to the 102nd floor, and more than 2 million square feet of office space. It has its own zip code. Its utilities, electrical, plumbing, ventilation, are grouped in a central shaft running the full height of the building, a design choice that allowed the office floors to be clean and open, maximizing rentable space. In recent decades, the building has undergone one of the most significant energy retrofits of any commercial property in New York. An $80 million sustainability program replaced all 6,514 windows with custom-designed insulated units, upgraded every major mechanical system, and reduced the building's energy use dramatically. In 2011, the Empire State Building received LEED Gold certification, a standard of environmental performance that didn't exist when the building was built. The observation deck was renovated into a world-class experience that in 2017 alone attracted 3.9 million visitors who paid a combined $124 million in ticket revenue. The building that nearly bankrupted its owners now generates more in observation deck revenue in a single year than it cost to build in 1930. There is a renovation story buried inside this one that almost nobody knows, and it is worth closing with. In 2019, the ceiling of the building's Fifth Avenue lobby was completely restored. The original Art Deco mural, an intricate metalwork design installed in 1931, had been painted over decades earlier and needed to be recreated from historical photographs and surviving fragments. The restoration team spent 20,000 working hours on the ceiling alone, 20,000 hours to restore one ceiling. The original construction of the entire Empire State Building, all 102 stories, all 57,000 tons of steel, all 10 million bricks, took fewer man-hours than it took to restore one ceiling in the lobby. That number says something about how the world has changed. It also says something about what the people who built this thing actually accomplished. They worked with less under worse conditions, with cruder tools, under the weight of an economy in collapse, and they built something so well that it is still standing, still occupied, still visited by millions of people every year, nearly a century later. The Empire State Building was born from ego. It was sustained by the observation deck and the stubbornness of men who refused to sell. It was vindicated by time, by economics, and by the slow realization of a city that it had something genuinely irreplaceable on its skyline. Engineers and historians both tend to say the same thing about truly great infrastructure. The highest compliment you can pay a structure is that it becomes invisible, that people stop seeing the engineering behind it and simply accept it as part of the world. The Brooklyn Bridge, the Hoover Dam, the Golden Gate. The Empire State Building is the exception. It never becomes invisible. You can walk past it every day for 40 years and still catch yourself looking up. It is still, after all this time, doing exactly what John Raskob said he wanted it to do on that evening in October 1929. Before the crash, before the emptiness, before the decades of struggle, it reaches for the sky. It just turns out that was enough.